In this video, I want to talk about an application of linear systems that is used in image rendering among many, many other things, and that's called interpolation. So interpolation just means, like, if you're given a set of points, you want to find the curve that passes through all of them, right? So this curve right here, this is interpolating this set of data points. And when I say it's used in image rendering in computer science, one application of that is what I'm doing right now. When I draw a curve with my pen on my tablet, the computer's not seeing a smooth curve. The computer is seeing lots and lots of dots, and then it has to connect them. So we're looking for, in this application, a way to find the equation of this curve that interpolates a given set of points. And the first kind of interpolation I want to talk about is really the easiest kind to handle, and that's called polynomial interpolation. And polynomial interpolation starts with a set of endpoints. And if you have a set of endpoints, you know how 2 points determine a line, 3 points in 2 dimensions will determine a parabola, 4 points will determine a cubic polynomial, and endpoints will determine an n-1 degree polynomial. So we want to find the polynomial. This is a unique polynomial that passes through all n points, and we'll just note that it will have degree n-1. So I think I can show you how to do this polynomial interpolation by just working through an example. Polynomial interpolation is not too hard. So here's a set of points and a plot of them. And what we're looking for now with this set of 5 points is the polynomial that has 4th degree that interpolates those. So our goal is to find the polynomial p of x of degree 4 so that it passes through all those points. And that is the same as saying, well, I need to find the coefficients of all the terms in an equation of this form, which is a polynomial of degree 4. And if I know those 5 numbers, then I've got the equation of the polynomial. So how are we going to do that? Well, we're going to set up a linear system, and the way it works is like this. So we know that when x is equal to 0, p of x, so p of x should be equal to 2. So let's write that down. So p of 0 is equal to, well, if I plug 0 in here, I'll just get e. That has to be equal to 2. And p of 1, if I plug 1 in here, I'll get a plus b plus c plus d plus e. And p of 1 I know should be equal to 2. If I plug 3 in, I'll get 81a plus 27b plus 9c plus 3d plus e equals 5. So you see how this is going. And that's our full set of equations. And you can see also that this forms a linear system in 5 variables, a, b, c, d, and e. Now, once we have this linear system set up, we can turn this into an augmented matrix that's going to have 5 rows, 1 for each of the points, and 5 columns, 1 for each of the variables. For this first equation, I have the coefficient of a, b, c, d are all 0. And the coefficient of e is 1. And then my right-hand side is e. For the second equation, the coefficients are all 1s. Sorry, my right-hand side is 2. And my right-hand side is 2 again. And in the third equation, we have 81, 27, 9, 3, and 1. We have 5 here. And so once we have this augmented matrix, we can compute the solution using Gauss-Jordan elimination. And what we'll end up with is this. And this is now in a reduced echelon form, and we can just read off what a, b, c, d, and e are. And that means we now know what our polynomial is going to be. So let me write that down up here, and then I can paste in a picture that I've got of this. So that's the polynomial, and here is its graph. P0 through P4 are our points, and then we've got this nice polynomial interpolating it, and we have its equation. So that is how you do polynomial interpolation. In the next video, I want to show you I can do a fancier thing that gives a little bit nicer results, especially when you're rendering hand-drawn things.